Oh my God, are you kidding me?
A couple warm-ups to get started. Both integral. One using like antiderivatives by hand, where you have to go backwards, know the antiderivative. The other integral using area under the curve with geometry. So give those a try, and then we'll go over them. All right, number one, antiderivative, 2t plus, and then the derivative of sine is cosine, so that means the antiderivative of cosine is sine. Now, if these limits weren't there, we would do a plus c and be done. But there's limits on there, so we're going to go from 0 to pi. So 2 pi plus sine pi minus, this is a little bit overkill here because 2 times 0 and sine of 0 is all 0. But you could leave that as a safe stop and be done and be fine. If you recognize all the zeros, then you might write it as 2 pi plus sine pi. Sine of pi is 0, so the multiple choice answer would be 2 pi, but any of those would be acceptable safe stops. I mean, even including this first one. So if you really didn't remember what the sign was, then leave it. It's okay. For a free response question. Number 2, and see, here's the point of doing both of these. They look kind of the same, but one you had to do by hand, and this one I give you a graph. So this means the area under the curve. So let's see, let's kind of break this into pieces here, and then we'll add up all the areas. So let's see, 2 times 2 divided by 2, that's a lot of 2's, but that area is 2. But since it's below the axis, it's negative. So I'm just going to label it negative 2. This is symmetric, so that's 2. And then that's just a rectangle, width of 1, height of 2. That's 2. So I add up all my areas, and I get 2. Because the 2 and negative 2 cancel each other out.
We could have used our calculator on either one of these if we really wanted to, right?
So good question. Could you use your calculator? You could not have used your calculator on number 2, because your calculator doesn't know how to read a graph.
Right.
But yes, if you'd have put this in the calculator, well, it wouldn't tell you 2 pi. It would have said 6.28 whatever. I mean, it would have given you the right answer. It just wouldn't have written it as 2 pi.
So wait, could we have just put in like the math 9 and then do negative 2 to 3? But if we left it with x, d of x,
But I mean, you could type that in, but the calculator doesn't know what f of x is, so he'd be stuck.
Yeah. Okay.
Now you can like really cheat your way around that. I mean, it wouldn't be worth the effort. But on the y equals, like if you somehow could figure out how to represent that function as a y equals, then you could do it in the calculator. But that would be way more trouble than just the point is the area under the curve. But I want to verify what you said, because it's a good question. Math 9, 0 to pi of 2 plus cosine of, I'm going to switch it to x, just because that's easier in the calculator. So that should give me 2 pi if we did our problem right. Right? And it doesn't list it as 2 pi, but yeah, it's 2 pi. Now, that's why there's a no calculator part of the test and a calculator part of the test. So they can test that you know how to do this by hand. If that showed up on the calculator part of the test, then you would not be expected to show anything except the answer. So if their calculator will do it, you can let your calculator do it and not have to, show a whole lot of steps. If there's a calculator ready expression sitting there, then you can do that. Now, that's not going to be a question on the calculator part of the AP test, because they know all you'll have to do is plug it in. So kind of like, what's the point? You haven't really showed much. But if that came up as part of another problem, then again, you just type it in the calculator.